Hello students, welcome to the Learner's Planet. This is our first problem solving session for chemistry paper of AIEEE 2007. In this session we will be solving around 10 questions of that paper. So students, in your AIEEE 2007 there were 40 questions in the chemistry section. So we will be solving 4 problem solving sessions for those, right? Now let's start our question solving session here, students. See, this is our first question. The energies of activation for forward and reverse reactions for A2 plus B2 gives 2AB are 120 kilojoule per mole and 200 kilojoule per mole. That is, your energy of activation for forward and the reverse reactions is given. The presence of catalyst lowers the activation energy of both forward and reverse reactions by 100 kilojoule per mole. The enthalpy change of the reaction in the presence of catalyst will be. So, what is it? You have to find out the enthalpy change for this reaction, right? Now students, if I plot a graph for the energy of activation as well as and the progress of reaction, how it is? See, the answer is 20. I am telling you, and it's you can solve it in 30 seconds. So this is on the y-axis. What is plotted is the energy, and on the x-axis we've got progress of reaction, right? So whatever reaction is this, A to 2AB, the forward reaction. Forward reaction is 180 kilojoule per mole. So, and the reverse reaction, that is backward reaction, it is 200 kilojoule per mole. So, if I plot a curve, what I'll get, see here, it is your 180 kilojoule per mole, and this is your backward reaction. So this is your E forward, that is, if I draw a line over here, so this thing is what? This is E forward. So this is E forward and this particular thing is what? The energy of the backward reaction, right? So this is E backward. Fine. Now this particular thing is the enthalpy of the reaction, right? I should have drawn the line over here. See, this particular thing is what? The enthalpy of the reaction, that is this, right? So this is your delta H. So your delta H is equal to what? E forward, that is your delta H of reaction is equal to E forward minus E backward. So see, this is the energy released in the forward reaction, this is the backward reaction, and this is the delta H, right? So what is the question here? That the presence of catalyst lowers the activation energy of both forward and backward reactions by 100 kilojoule per mole. The enthalpy change of the reaction in the presence of the catalyst would be, so in the presence of the catalyst, what is E forward? The activation energy of the forward reaction in the presence of catalyst, it comes out to be 80 kilojoule per mole, and the energy of activation for the backward reaction in the presence of catalyst is how much? It will become 100 kilojoule per mole. Right? So what will be the delta H of the reaction in the presence of catalyst? It would be 20. Right? That is, your delta H is equal to 80 minus 100, and that is equal to minus 20 kilojoule per mole. Right? That is, it is what? It is an exothermic reaction, and this is 20. Right? Say the forward reaction is an exothermic reaction. Okay? Or this complete reaction is an exothermic reaction. It is 20 kilojoule per mole. Right? So this was very simple question, students. Just remember that the enthalpy of a reaction is equal to the activation energy of the forward reaction minus the activation energy of the backward reaction. Fine? Now let's take up our next question. Yeah, we've got this. This cell, this is an electrochemical cell. That is your zinc ions, copper, and electrode potential of the cell is 1.10 volts. Was allowed to be completely discharged at 298 Kelvin. The relative concentration of Z ions to copper ions is. So you have to find out the relative concentration. So, what is the formula you're going to use here? Of course, the Nernst equation for the electrode potential of a cell. So, E cell is equal to E naught cell, right, minus 0.0591 divided by what? N, that is the number of electrons. So it should be divided by N, right, and log of the concentration of the anode electrolyte upon the concentration of the cathode electrolyte, or the electrolyte in which cathode is immersed. Right? Now, the cell is completely discharged. It means what? The potential of the cell is equal to 0. Right? Because your cell is completely discharged. Okay. Now, your E naught cell will be equal to 0.0591 divided by N. So how many electrons have been transferred? Say your zinc is acting as an anode, so zinc will be zinc plus Cu2 plus ions will be giving Zn2 plus ions plus Cu. Right? So how many electrons have been exchanged over here? There are the 2 electrons. Right? So N is equal to how much? 2. Then log and Zn2 plus Cu2 plus. Right? Now your E naught cell is given as how much? 1.10 volts, right? So this would be 1.10 into 2 divided by 0.0591 is equal to log of Zn2 plus upon Cu2 plus, right? or the concentration of Zn2 plus by Cu2 plus is equal to what? Anti-log what? Anti-log 0. Or this is 1.10 into 2 divided by 0.0591. So that is 37.22, right? So this would be 37.22, or this can be written as 10 to the power 37.3. Right? So the concentration ratio of your Zn2 plus to Cu2 plus is equal to 10 to the power 37.3. Fine? So what is our answer? C. Right? So this was your question from your electrochemistry, right? Now let's take up our next question.